Hi guys, welcome to the second episode of 10 Minute Topic. Today we'll be diving into the integrated science syllabus and we'll be looking a bit at the electricity and lighting topic. So today we define and compare conductors and insulators. We're going to discuss a few uses of conductors and insulators in the kitchen, and then we're going to talk about the electricity and lighting. So we're going to give some definitions and some formulas. And finally, we move on to that question. So conductors and insulators. We know what this is. We've been talking about this for a very long time. Conductors, this is materials that allow electricity or heat to freely flow through them, while the insulators are materials that do the opposite. They do not allow the electricity or heat to freely pass through. So we have a list of materials here, and we can figure out which is a conductor, which is an insulator. So for sure, we know plastic is an insulator. Copper is a conductor. We use this in a lot of the wires or plugs, that we have. So our chargers and everything, you find that copper there. So pickles. This vegetable here, is it a conductor or insulator? Well, remember, cucumbers has a lot of water in it, has a very high water content, and water is a conductor. So the pickle is going to be a conductor, and through the process of pickling, a lot of salt is added, and salt increases the conductivity of water. So pickles would be a conductor. We have fabrics, these are going to be insulators. Wood, it's an insulator, and metals, for sure we know this is a conductor. So if we had to think about all of the different equipment or things that we have in the kitchen, we can figure out a lot of insulators or conductors. So we have metal pans, we have wooden spoons, that's going to be an insulator. We have metal spoons, that's going to be a conductor. We have baking sheets. We have like kettles, electric kettles, and all of these things they're just made out of iron or metal, right? So we look at one specific example here. We have the pan, which is made out of metal, and we have the pot holder, which is made out of an insulating material. The metal pan is obviously going to be a conductor, and it has to have that property to allow the food inside of it to cook. So most of the pans we have would either have a wooden or a plastic casing on the handle to allow us to hold it. But if it doesn't, then we would have to use the mittens or the pot holders to ensure that we do not burn our hand. And it allows us to do this because the material that it is made out of is insulating material. So energy. What's a golden rule when it comes to energy? We know that energy can neither be created nor destroyed. It simply is turned or transformed into different forms. So electricity is a form or type of energy, and it results from the existence of charged particles either through static accumulation or electric current. And this is why if we have a circuit, the circuit has to be made out of conducting material to allow the free flow of electrons throughout that entire circuit. And once the circuit is complete, then whatever appliance we have attached to that, it will get the required energy for it to work. So in our homes, most of our appliances use a cable which is known as a flex, and it has a 3-pin plug which is made out of brass. We have to know the wires that you'll find inside here. You have the live wire, the earth wire, the neutral wire, and we also have the fuse here. But this isn't part of what we'll be talking about today. So let's say this very horrible drawing. This is a fridge, right? So we have the freezer at the top, we have that at the bottom, and this here we have the main. So I'll just put M with the main, and I'll put A because this is the appliance. The live wire carries the electricity to the appliance. The neutral wire completes the circuit by carrying it back to the main. And in case of any faults or any damage with the appliance, to prevent someone from becoming electrocuted, we have the earth wire, which is going to be grounded. So any electricity will be grounded and prevent you from becoming shocked. So it's there for safety reasons. So you have to remember the color of these wires. The live wire is brown, the earth wire is green and yellow, and the neutral wire is blue. So electric power is the rate per unit time at which electrical energy is transferred by an electric current. And the SI unit that we use for electric power is the watt. The watt is equivalent to 1 joule per second. Because remember, the unit for energy is the joule, right? So it's 1 joule per second. But when we're calculating it, when we're calculating the energy transfer, we don't just use watts. That unit is too small, so we have to use the kilowatt. So you have to ensure that any question that you are doing, it's kilowatts. If it's in watts, you have to convert it into kilowatts. So if you have 1000 watts, this is going to be 1 kilowatt. If you remember your conversions, it's 1000, so we go back 1, 2, 3, we put the new point here. So you will get 1.0 kilowatts. And time always has to be in hours. So if it's in minutes or seconds, you have to convert it. So the energy transfer is in kilowatt hours. And it's in kilowatt hours because it's power, which is in kilowatt hour, multiplied by time, which is how long you have been using that appliance or the appliances, which is going to be calculated in hours. And how do we figure out how much money we have to pay? Well, this energy transfer here, so the number of kilowatt hours, you multiply by the cost per kilowatt hour. So the electric companies will have a rate. So let's say 1 kilowatt hour is going to cost you 25 cents. If you've been using it for the appliance for 4 hours, then it will be 4 multiplied by 0.05, which will give you $1. Simple enough. So today's question is from the CSEC past paper Integrated Science, and it's 2014. We'll be looking at question number 4. So by now, I would assume that we've seen the front page of the exam paper or any exam paper already. It's same or relatively same for all, it's just the instructions would change based on the exam and also the time. So let's get into it. So remember, all of this is going to be based on what we just discussed. The first question here is to distinguish between a conductor and an insulator. So I'll just write something shorthand. So what you'll put is just one mark, so we know that the conductors, they allow electricity or heat to freely flow through them. So you can put something like allows, I'll just put capital E for electricity, but you write out electricity. So it allows electricity, or H for heat. So it allows electricity or heat to freely pass through it, while the insulator does the opposite. It does not allow electricity or heat to pass through it. Simple enough, you get your 2 marks here. Now part B, state one example of how a conductor is used in the kitchen and one example of how an insulator is used in the kitchen. So for this we can use any example, and the most common or the easiest example we can use is the pots or probably baking sheets. So you
Music
the use of
licensing
a conductor in
reimagined.
the kitchen, you can say that the metal, or you can specifically say aluminum, is used to make pots, and these pots are conductors, or the material is a conductor. So it allows the food inside of the pot to be cooked, or water inside of the pot to boil. And then the use of an insulator in the kitchen. We have many different ones that we can use, but we can again stick with the pot. So we can talk
Artlist.io.
about the wooden or the plastic handles. So the fact that at the end of the aluminum pots, we have plastic handles or ceramic handles that are not conductors, so they are insulators. It allows us to hold the pots or the pans without getting burnt. Or we can use
Music
the
licensing
oven mittens
reimagined.
as the example of pot holders there. I wouldn't put anything, but we just spoke about it. So you can put anything there. And the same question, I just brought it over here. So here now, part C, in a practical activity, Ryan was asked to connect three wires to the live, earth, and neutral contacts in a three-pin plug. The complete table 4 to show the colors of the wire that should be connected to
Artlist.io.
each contact. So remember, we just looked at that. The live is going to be our brown wire. The earth wire is that
Artlist.io.
yellow and green, and the neutral wire is going to be our blue wire. And finally, we're looking at the quantity of electricity used here. So we have some
Music
calculations to do.
licensing
So part
reimagined.
D, a housewife wants to determine the weekly cost of using three appliances in her home. So if 1 unit of electricity in kilowatt hours costs 25 cents. So we'll highlight this here. That's the rate. So it costs 25 cents
Artlist.io.
to calculate the cost. We're taking the cost of using
Music licensing reimagined.
converted into kilowatts. So even if this space wasn't given here, you would have to remember that the we have to convert watts to kilowatts. The stove, she uses 1500 watts. This is going to be 1.5 kilowatts. The washing machine, 1000 watts. This is going to be 1.0 kilowatts. And the fan is
Artlist.io.
250 watts. This is going to be 0.25 kilowatts. Now, how do we figure out the units of electricity consumed per day? Well, we have the hours used. So this is in hours. We don't have to do any conversions here. So the
Music
rating, or to
licensing
find out how much is
reimagined.
consumed, it's going to be the rating in kilowatt multiplied by the amount of time she has been using it. So it's going to be 1.5 multiplied by 5, which is going to give us 7.5 kilowatt hours. We have 1.0 multiplied by 2, which is going to give us 2.0 kilowatt hours. And
Artlist.io.
we have 0.25 kilowatts multiplied by 10 hours, which is going to give us 2.5. So the total here is going to be 7.5, 2, and 2.5, which is going to give us 12.0 kilowatt hours per day. So remember that this is per day. The bottom here, we have to figure out how much is used in 1 week, which is 7 days. So that is going to be 12 multiplied by 7, which is going to give us 84 kilowatt hours. And the cost for the week is going to be the
Artlist.io.
amount of energy used for the week, multiply by the rate, which is the 25 cents. So that is going to be 84 multiplied by 0.25, which is going to give us $21. So that's how much money it is going to cost her to use these three appliances at the rate and the amount of hours that she used it for that week. So if we do all of this, we'll get the 6 months. And the last part, state 2 ways in which energy can be conserved in the home. So looking at this, we could figure out how energy can be saved. What can she do to reduce the amount of energy that she is using? Well, we can talk about the stove. The fact that the stove takes the most, right, 1.5, and she's cooking 5 hours for the day. If we want to reduce the amount of energy that we're using there, then we can suggest that she has specific days that she cooks. So let's say she cooks on Monday, she can cook enough so that the food would last throughout Tuesday, then cook on Wednesday and so forth. So she's reducing the amount of time, the amount of energy that she's using to cook 5 hours per day. We can also say that if we could take that step, she can use a gas stove or a stove that uses gas instead of electricity as well. We can give that suggestion. Or we can also talk about the washing machine. The fact that she washes 2 hours per day. Just like the cooking, we can say that she can have specific wash days. So she washes twice for the week or once for the week or something. And with fan, we can say that the fan could be used only when someone is in the room. So once someone is using it, then you put on the fan. If you're not in the room, you take off the fan. So we can reduce the amount of time the fan is being used, even though it's not costing too much money to use it. So that brings us to the end of the second episode of 10-Minute Topic. Remember to like, share, and subscribe so you will never miss an episode. If you made it to the end here, I'm thankful, and I really hope that you enjoy the content. I know that it was more than the 10 minutes, but I did say in the beginning, disclaimer, it might be more or it might be less. So remember to share it with your friends, let them know, and feel free to leave a comment below letting me know which question or which past paper you'd like us to tackle next. Bye.